Hello, we are Team 8 and we would like you all to think about how the problems that bottlenecks at energy generation and distribution cause in our world today. Mid of July 2019, not long ago, a major power outage took place in Manhattan. While some subway riders were stuck meters underground in pitch darkness, others were suspended hundreds of feet above ground in high-rise elevators. Traffic lights were off, and for 5 hours, more than 47 blocks were in darkness, including Times Square. Big cities cannot risk to have blackouts. The problem is not lack of energy, but problems at the distribution. The country's century-old centralized plants were vulnerable to weather conditions and to other minor disturbances like, for example, squirrels chewing off of cables. People spend a lot of energy when using fitness machines. This energy is wasted. Gyms could benefit from this energy using it to self-power, reducing the energy consumption from the grid. On the other hand, cars were slowed down by speed bumps on the road, wasting energy on the impact. This energy can be used to run traffic lights or warning beacons in the area. Part of the solution to this problem is restructuring the grid by decentralizing power supply. In other words, creating small-scale sustainable technologies independent from the energy grid. Hence our proposition of transforming kinetic energy into electrical power. Think of common distribution networks where power needs to be transported from a central power generation plant. Now, imagine that this power can be generated and distributed right there where it is needed. To transform from mechanical energy into electrical power, you need mechanical devices, for example, a system of rack and pinion, and a generator. The energy is stored in a battery if the grid does not consume it or sent to the grid. Now, in order for this technology to be accepted, it needs to show a cost benefit. If we take New York City or Boston, where the cost of energy is above 20 cents per kilowatt hour, we can see how this technology can be interesting. Let us look at two similar fitness centers to illustrate the point. The first one, a public gym with 20 treadmills and 20 static bikes, operating 25 days per month and an average of 5 hours per day. Let us assume 50 light bulbs lighting the gym for 8 hours per day. The estimated energy consumed by the gym will be almost 6,000 kilowatt hour, with a cost implication of over $1,300 monthly. Now, the second gym, operating the same hours and with the same number of machines, but using this technology, will have a cost advantage over the first gym because it will consume only a little over 5,000 kilowatt hour of energy per month at a cost of $1,140, allowing them to save around $180 in this period of time. This totals up to $2,060 in annual savings on power. By the way, this gym generates 860 kilowatt hour of energy monthly for a total of 9,600 kilowatt hour annually. Also, it will depend less on the common electrical grid. Many Americans prefer energy that comes from renewable sources. This is a great incentive to join a gym That makes a difference where you can generate power and be sustainable. Similarly, the technology can be used to produce energy on the roads, where speed bumps are needed near schools or pedestrian zones. Energy can be used to run traffic lights and signal beacons. A great way to use energy of cars passing over speed bumps. Thank you very much for listening and watching, and we will be taking questions now.